It is a truth universally acknowledged that humans are very bad at being random. We're very good at saying that we're random.
Why is the sun so hot?
Yellow.
What are...
Like if you go up to 100 people and ask them to pick a number between 1 and 4, very few are going to say 1 or 4 because it doesn't feel random. People are going to say 2 or 3, probably 3. Now, because humans are not good at being random, we can represent random outcomes using things like a coin flip, or rolling dice, or pulling cards out of a deck of playing cards. We can also use a random digit table. A random digit table is just a list of random numbers created by a computer that actually isn't totally random. The computer starts with a number or a couple numbers, I think. It's called a seed. And then it does some really complicated calculations or operations or like an algorithm to create something that isn't technically random, but to the human eye looks random. Quite often, the random digit table is kind of split up into columns, and there's no reason for that other than making it easier to read. So here's how we use a random digit table. Let's say we have two different outcomes, A and B. There's a 30% chance of A happening, 70% chance of B happening. What we need to do is assign digits to represent A and B. For this example, I'm going to look at one digit at a time. So I have the numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is 10 digits total. I know it seems like it's going to be 9 digits, but remember 0 is one of our digits, so this is 10 digits. 30% of these digits need to represent A. So of these 10 digits, I'm going to have the first 3, 0, 1, and 2, represent A, and I'm going to have the last 7 represent B. So as we go through the table, if we get a 0, 1, or 2, that'll be A, and if we get anything else, it'll be B. So, the start, we have 1, 1, 1. So the first 3 outcomes are A, A, A. 6, 4, those are both B's. 3, 6, 3, those are all B's. 1, back to A. 8, back to B. And we could keep going as long as we need to. So that's one way of using a random digit table. But if we change A to be a probability of 35% and B to be a probability of 65%, we can't use the digits 0 through 9 anymore. There's no way for me to represent 35% if I only have 10 options. So this time I'm going to think of two numbers together as a single outcome. So instead of 1, 1, 1, 6, 4, this would be 1, 1, or 11, 1, 6, or 16, 43, 63, 18, 75, 6, if there's a 0 in front, we'll just call that 6, 13, and so on. So let's think about all the options I have if I'm looking at two digits at a time. So 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, all the way up to 99. Because after that, I'd get to 100, and we're only looking at 2 digits, not 3 digits. Okay, so if I want a 35% chance of A happening, I need the first 35 numbers to represent A. So 1, 2, 3, 4, 5, all the way up to 34 would be the first 35 numbers. I know it seems like we should go up to 35, but remember, 0 is our first number in this list. So 0 to 34 would be 35 numbers. 35 through 99 can represent B. So 11, that's an outcome of A, 16, A, 43, B, 63, B, 18 is A, 75 is B, 6 is A, 13 is A, you get the idea. It doesn't always have to be that complicated. Like if it's a 50-50 chance of A or B, you could just say like odds are B, evens, and 0 is A. You know, that works too. All right, the next time you're with somebody who says, oh my God, I'm so random, you can point them to this video so that they can learn what random actually is. Or not. That's probably not a good way to make friends.